This is today from Mr. X continuing with a graph. Okay, so today we are going to solve this problem. Clone the graph. So we need to clone this graph. So let's go first go through the problem and then we'll try to solve this specific problem. Okay, so given a reference of a node in a connected undirected graph. So it is undirected graph first thing. And return a deep copy clone of the graph. Okay, then so each node in the graph contains a value int and a list node. Okay, it has an neighbors. So class node valve and its neighbor. Okay, so test case for the simplicity sake, each node value is the same as the node index. For example, the first node is val1 and the second node is val2 and so on. The graph is represented in the test case using a adjacency matrix. So graph is represented in a test case using an adjacency matrix. An adjacency list. Okay. List matrix list is a collection of unordered list used to represent a finite graph. Each list describes a set of neighbors of nodes in a graph. So the given node will always be the first node, that will be val1. You must return the copy of the given node as the reference. So if we have given this original, we need to create a new node in a different specific memory location. Okay, so what we're going to do is simply from the node we'll create a adjacency list. Okay, and from that adjacent list we'll create another tree. Okay, so what we can do is simply is let's start from the root node. Okay, so let's first create a map of that will be what is this, we have int as well. So let's do int. Okay, int and vectors of int. Okay, so always this neighbor and itself neighbor and the node will always be different. Okay, that's sure, that's we can be sure. Okay, so what we can do is we can create graph. Now let's have a because of undirected graph we need a list of visited nodes. So that for that create an unordered set of int. Okay, let's name it visited. Okay, now what we're gonna do is start from this node. Okay, till when because we have val and its neighbor. So we'll start and we'll do well. We'll add this node to the top of the stack. Then what you're gonna do is okay. So simply let's create another stack. Okay, stack of int. Okay, let's create a stack of node. Yes. Okay, while yes while stack is not empty, what you're gonna do is we are going to pop. So let's add the first element, stack push. Let's push node. Okay, let's get the top element from the stack. Okay, so the top element from the stack, that will be as the top. Okay, so now once we have top, we need to pop the top element from the stack and mark it as a visited. Okay, let's mark its value as visited. TD visited dot. Okay, for insert whatever t value. Okay, so now what you're gonna do is simply let's go through its neighbor. Okay, for each that will be node star GHP your neighbor in of top dot what its neighbors is. Neighbor. Okay, go through all of its neighbors. See if instead find let's find if our neighbor valve if neighbor valve if it does not exist. If it does not exist, what I'm gonna do is if it does not exist, we are going to add it to the stack. Add it to the neighbor. Okay. So we need to create adjacency list. So how are we going to create this? Okay. So simply let's instead of if we have already added, we still need to add it. Uh, let's say we have visited this one and we have added this one. So we'll have one bracket on to the when we reach this. Okay, we still need to add these and this which never to agents adjacent list. Okay, so what we're going to do is inside the for loop we'll do its graph dot whatever our t value is, whatever t value is, since push back. Now we have our adjacency list. Okay, we'll keep on doing this until all the nodes are visited. Once all the nodes are visited, uh, we have popped. Okay, so all the nodes are visited. We have popped this node. So let's see if this gives any error or not. Before that, let's create a result node. Okay, so let's create a node. Let's name it result. Okay, it will do nothing. It will be null. But let's return that. So see if there is any compilation error or not. Check for compilation error. Stuff neighbors. Let's in IGHPORSCIGNE. Sorry, not stack S. Step push. Sorry. Well, let's see if we do not get in any infinite loop. Instead of pushing, let's push it. Well, something. Let's so that we do not get any error will return null pointer runtime is within null pointer of added. Okay, the node can be empty too. Okay, so the given last expected input. So input can be null too. Okay, so if it is null, what we just return was the case. If it is null, we just return null. Okay, if pointer, all you need to do is return expectation. So now we have our adjacency list. Okay, now we'll go through the adjacency list and create a node and its sub node. And what we what we're gonna do is, let's say now we have adjacency list. We'll start from the graph. So we'll take a node and create that node and create all of its children node if that does not exist. So what we're gonna do is simply let's have a, let's say that instead of visited, let's have a node, let's create it. So if we have already created a specific node, we'll just add that node to this one. So let's do ordered data of nodes, node pointers. Let's name it created. Okay, so what I'm gonna do is for each pair in each graph. Okay, so each auto pair graph, what I'm gonna do is pair at first. So we creating, let's see, no, instead of this, let's have an int. Okay, so let's check if pair first. And this should work. Let's pair that first. There is value. Let's see if we have already created one. Before doing that, uh, we'll take a first value. Okay, first value, whatever the value is, and let's see if it is created. If pair, okay, created, let's see, get 0 of pair. Okay, if we created that. Okay, so if whatever node we are on, see if that integer with that value, that pair, that first value, let's say we have 1, let's see if 1 is created or not. So 1 is not created, what are when I create a node, so node pointer, let's create and sorry, and it's going to, that will be, how do you create, you can create it like this, or you can do new node. So it's a pointer, we need to do new node. Okay, let's pass in values. So let's pass in pass in 0 pair as its value. Okay. Okay. Now for its neighbor, what we're gonna do is we'll loop through all the adjacent all the value and keep on creating and adding. So let's first add this current node to the created. Okay, we created this node. For the first node, create a bool is first. Okay, by default false. So if is first is false, what we do is result is equal to n. Okay, then first will be first will be yeah. So if this is the first node, we'll make the result to this, and then we'll have this. Then what do we need to do? Add creative and CRT insert. Let's insert what value. Okay, so that then we'll loop through all its children. Okay, for each children. Okay, each children of the node. So for each that will be vector of integer. So the is a vector of int I in neighbor. That is uh, pair. Sorry, get one pair. Okay, second value. Loop through all the second value. Create it. Create it. In all the value. Need to create it. So first we need to check if it is created or not again. Check if it find I if it is not created. If it is not created, then but if it is not created, then create it and add it. But we cannot do this. We need it as node because if we don't have that this as a node, how to if even it's created, how we're going to assign it as a neighbor of this one? Okay, what I'm gonna do is this if paired first. This let's see if Cannot even do this. Created int another. It's created. Yeah. Clear this node. We mark it as created. Okay, we mark it as result. Then for these two, what we do is with these two as neighbor, we create these two nodes. If not created, we create this node and add to its neighbor. Okay, current neighbor, and we add these two nodes to its neighbor. Then in next iteration, we'll again come up if 2 is created on 2 is already created, so we skip. So I go to 3. 4 is also created. So both has created. So we go to 3. So 3 is not created. And 3 neighbor are 2 and 3. If 3 is not created, we create the 3 and 3 neighbors, that is 2 and 4. So we need to attach these. It's bidirectional. No? So we first to create this, we mark these two as its neighbor. Then once we come up here, we'll again create this node. Instead of having this as a created, what we can have is as a vector of whatever the graph size is. Okay, so that big, as we know that we have 1, 2, 3, and 4. We'll add starting from 1. Okay, now that starting from 1, we have at one position its node we created. That one, let's create a vector. Vector of nodes. Vector of nodes. Let's do. So okay, let's make it size of it's crafted. Size. Okay, the graph size is +1. Okay, what we do this, and if it is not created, we create it and set its value over here. And what we do is we issue nodes whatever n value is, what we're gonna do, push and okay, there, push it over there. Okay, and position we push it if it's not created. We were creating it here, like pushing it over here. Now once we come up here, we have I. We can check if it is not created. If it is not created, what we do is simply let's again do the same thing. For instead of n, then ei. Okay, let's do it in ei. Okay, I then ei. Okay, so we get those more to add it to the insert and add it to the value. Okay, Then to create that specific node, we need to do n, what with the above n gh bor dot push back. Okay, push backwards never. Let's say we have one, so we create these two. If we have one is not created, we create one, we add to created. We have 2 and 3, we create these two also, 2 and 4, and we created 2 and 4, we mark it as created, and at that specific node we do this, we add it. Okay, so that's fine. Now when you come up here, so we see if 2 is already created. So 2 is already created, so we are again creating it. So we say 2 is already created. So 2 is already created. So what we do is, we do not create 2, we just create its neighbor and add it to the, just do this, create its neighbor and add this to this. Let's say we come here 1, then we'll come to 2. 2 is already created, so 2 is already created. It's here. If it is already created, what you do is you just check its neighbor. Okay, so these and these, copy this. Else, if a node is already created, what we do is we get that pay that second. We look to the second, we check if it is created or not. Then we go to 2. 2 is already created, we do nothing, we do not create 2 again, we just go through 2 neighbor, that will be 1. So we check 1 is also already created. So what we do is, if it is already created, if I, that is int I is already created at I, what you do is simply create at first, that is value, that is 2. So 2 is already created, that will be at node 2. So nodes, that is 0. It's first is already created. So what you do is simply come here, go to the 2's neighbor. So to go through the 2 neighbor, what it is, for each int I in, instead of at the index 2, it's nodes that the, this was returning nodes. So this would return and we go to the 2. 2 is already created. So 2 is already created. Go to the 2 values. So 2 is already created. We just go to the 2 values. So that will be these. Okay, so that is also correct. Go to the graph second value. Say if that value is created like 1 or 3, 1 and 3 is not created. Let's say 3 is not created. So what we do is we go come here, create 3, we push it, then 1. Let's say if 1 is already created, if 1 is created, is created. So 1 is created. What we do is We know that in ith this index, so that is current index pair index. Yes, we have ch por the uses push back. What do we push back? Once push back node I. Keep going if I it's not variable push back node I. If it's not variable, we just at that index, whatever the value is at that index, add it to the group. Okay. So this is done. Same thing over here also. Okay. It is just say if the specific neighbor node is already created itself, let's say 3 itself is not created, but let's for some reason let's say 3 is not created but its neighbor node are created, so we create the 3, we check over, so 2 exists, so all you do is at whatever current node index at index 3, at index that is 3, get me the nodes are in this 3 and push its neighbor as this. It does not work. So vector of int, but this vector of an int. We cannot convert int to vectors of int. Sorry, this will give us int. Center. Yeah, if this works, must return the copy of the node as a reference. Expected this. We are getting either list or are we getting nodes? We are getting node. We especially get like we are getting node. Let's say we are getting this. There's a start and its neighbor. Are we getting this? We're not. We're getting the first node and its neighbor. Clearly specific. Copy this. Let's put it into the chat GPT. So let's go down using the valve as a unique identifier. This treats valve as a unique identifier, but when in general, when nodes valve are not guaranteed to be unique. They said it's unique. They said it's unique. Like that, here it is written as first node valve 1 and second node as valve 2 and so on. The line here is a major problem. You will see we added first instead of valve instead of doing it like this. We will have done we added the file instead of first one. Instead of the compilation error. The second one. We added the second. We do not find I. Let me move it. I as a value. We added first already exists. So if I exists, let's say if this element exists, so what I'm gonna do? Whatever the element, sorry, exists and and so I live sir, live sir.
అవును లైవ్ స్ట్रीम आंदी छे ट्विच में
नहीं यूट्यूब
हां
यूट्यूब
कोई व्यूअर पनि छ
हाँ 50
हां
बढ्दै मतलब
हेरिरहेछ तिम्रो भिडियो
पाल्दै मतलब त्यसपछि अनि first this one first never yes we just add it and have the value we create this pattern we add it second value okay second let's focus also what it is if our pair dot first exists what we do is pair dot we go to pair dot second see if pair dot second has its values created if it is created it exists so what index it will exist it will exist at whatever the pair dot first value is whatever the value is at that index it will exist exist at let's say if two exist already exist in the created so whatever we're doing is we're going through the two loop two children two children instead of nei.nav, which does so instead of always these nodes create first created first of two exists at the two index nav we are adding this nav. Okay. Index position. We need to just keep on going and adding the element to the children. If it does not create it, we insert it, we add it, then at that index, then we do this, keep on doing this. Then if it already exists, at what index, whatever the I value, if I already is at I index there is a value. So we add that as okay. We improved a few blocks, like for example, I the overall approach still fundamental design is but that will break the edge cases. Let's go this to so in this vector value are 1 and no gaps. Well, in 20 we graph two size 3 that okay, let's visit.
Hey everyone, welcome back, and let's write some more NeetCode today. So today let's solve the problem clone graph. So we're given a reference to a node that is in a connected undirected graph, so it's convenient for us that the graph is completely connected. And all we want to do is return a deep copy of that graph, in other words, a clone of that graph. And for every single node, we have two things. We are given a value, and we're also given a list of its neighbors. So this is what's telling us, how the graph happens to be connected. These are the edges in our graph. Now, if you're not super familiar with what a deep copy is, so let's say that this is our example, our input graph. We're not just going to create a shallow copy, meaning like this is the exact same graph, like the color is yellow for both of these, meaning like it's the exact same graph. We didn't actually create a clone of it. So this is not what we're looking for. This is also not what we're looking for. So this is a new graph because the color is slightly different. But you see that the values aren't exactly how they're supposed to be. We have a 3 here, whereas we have a 2 in the original graph, right? So basically we have these 2's values mixed up. So that's not what we want either. We want an exact clone. So it has the exact same structure and values, right? The values and structure is the exact same. And this happens to be a new graph. This is not the exact same graph as this one because this one is blue, whereas this one is yellow. So how are we going to solve this problem? Well, you can see I'm going to use a hash map like pretty much every graph problem, and we're going to use depth first search, where you can also use breadth first search if you want, but let me show you the general algorithm. So you can see these edges are undirected, meaning, if 1 has a neighbor 2, well, 2 is also going to have a neighbor 1 in its neighbor list. So let's say that 1 is our entry point in the graph. What are we going to do? You can see initially our hash map is empty. What we're going to try to do is map the old nodes to the new nodes, or the copy nodes. So we start at 1. So what's the first thing we should do? Well, obviously we should create a copy of this node. That's what I'm going to do. So create a copy of 1. Now this copy of 1 is not complete yet, right? Because take a look at the original one. It has 2 neighbors, 3 and 2. So what can I do? We know we're going to have 2 neighbors for node 1, right? Can I just take these 2 original nodes and then put them over here, 3 and 2? No, I can't do that because for these nodes 3 and 2, we actually have to create copies of them as well. So you can see that this is going to be recursive. So first thing I'm going to do is I'm going to go to its first neighbor, which let's just say it happens to be 2 in this case, right? So I'm going to start cloning starting at 2. So we're at 2, we're going to create a clone of 2. Oh, and by the way, before I forget, before we make a clone of 2, we know we just created a clone for 1. So what are we going to do? We're going to map the original node 1 to its now clone node 1. So we're mapping the old node to the new node. And I'm going to show you why we're doing that in a second. So now we're going to go to node 2, right? And we're going to create a clone of node 2. So let's create that clone node 2. We're also going to add it to our hash map, right? We're mapping the old node 2 to its clone. So the clone in blue is the new node. So now we've cloned 1 and we've cloned 2. And for 2, now let's look at 2's neighbors. Well, look, you can see that it has a neighbor of 1, right? And it has a neighbor of 4. So first we're going to end up trying to do is create a clone for 2 because we know that we have to, in the list of neighbors for 2, we have to add the clone 1, which we haven't done yet. So what we're going to end up doing is we're going to try to clone 1, but we're going to see in our hash map, look, we already ended up cloning 1. So basically what I'm saying is now we can say, okay, we can add this edge that 2 is connected to 1, that 2 has a neighbor that happens to be 1. And basically the reason I'm doing that is because we know this edge is going to be undirected. It goes both ways. So that's what I'm trying to do here. So now we know that 2 is connected to 1. We also know we have to clone node 4. So now we're going to visit position 4. Let's create a clone for 4. So let's add it to our hash map as well. We're mapping the original node 4 to its clone. So now we're at the node 4. We want to clone 4's neighbors. First, you see that 4 has a neighbor 2, which we already cloned. So we're going to take this original node 4, right? We know the original node 4 has an original neighbor of 2. So then we're going to take that 2, look it up in our hash map, see, okay, we already created a clone of it, and this is the clone. And then we're going to end up taking 4 and connecting it to 2. And let's just say that, when we created the node 4, we ended up connecting 2 to 4. So let's just make this edge go both ways. Already created a clone of it, and this is the clone. And then we're going to end up taking 4 and connecting it to 2. And let's just say that, when we created the node 4, we ended up connecting 2 to 4. So let's just make this edge go both ways because we know that originally the edges are undirected. So now that for 4, we wanted to create a clone of 2. We also want to create a clone of its second neighbor, 3. So now let's create a clone of 3. So we know that 4 is going to be able to connect to this neighbor of 3. So we're creating a clone for it. And we're going to take the original 3 node and map it to its new copy node of 3. So now we're almost done, right? You can see that all 4 of the nodes have been copied, but for 3, we haven't added 3's neighbors, right? 3 isn't ended up connecting to any other nodes yet, but we know in the original 3 has 2 neighbors. The first neighbor is 4, so we're going to say, okay, we know that this 4 needs to have a clone, but the good thing is we already created a clone for that node, and this is the clone. So now we have it. So we're going to take 3 and connect it to 4. So we're going to make this edge basically double directed. And 3 also has another neighbor of 1. And so basically what we need to do is make a clone of that 1, but we look in our hash map first and we see we already cloned 1. This is the clone. So we're going to take 3 and connect it to 1, right? But wait, we have one last problem, right? This 1 should also be connected to the 3, right? You're right, and that's what we're doing recursively now. So we originally started at 1, then we went to 2, then we went to 4, then we went to 3. Now what we're going to end up doing is reversing that, because we remember we're doing this recursively. So we're going to pop back up to 4. We're going to see 4 has already cloned its neighbors. 3 already cloned its neighbors. We're going to pop back to 2. 2 already cloned its neighbors. We're going to pop back to 1. 1, we ended up cloning the neighbor 2, right? But we didn't end up going this way. So from 3 now, we're going to end up checking, okay, did we already clone 3? Let's look in our hash map. Yep, we already did. So this is the clone that we created. So all we really need to do is make 1 connected to 3. So basically make this edge double directed. So now you can see that we finally created a complete clone.
Get 1, then we check its neighbor. So that is neighbor, that is simple over the BFS. Okay, so you got a 2. What is the current element? Then we push whatever we push, we connect it to the we'll create a 1. We'll go through this one. So 1, we create another 1, map it. Okay, then go over go to this second iteration. We go to its neighbor. So it will be this one. Okay. This one. We're doing PFS. So we have already visited, we mark it as visited. We have already created this one, so we have to go back to this one. So,
of the graph, we did this in O of n time, where n is basically the number of edges plus the number of vertices, right? The number of nodes plus the number of edges connecting them, because we have to basically make a clone of each of these. And with that being said, now let's jump into the code. So we remember that we only need a single data structure, old to new, which is a hash map mapping the old nodes to the new nodes. And I'm going to implement this in depth first search. And you can see that this function is nested in the outer function, which just makes things easier, meaning that this data structure doesn't need to be passed into every single function call. But we do need to pass in every time the node that we're visiting. So in depth first search, we're going to pass in the node. First thing we're going to check is if the node is in our hash map. If it is in our hash map, then that means we already made a clone of it. If we already made a clone of it, then I'm just going to return that clone. We don't need to create another clone. So if it exists, return the new node. So if this statement doesn't execute, that means a clone doesn't already exist. So let's create that clone. I guess I'll call it a copy. So we're going to create a copy of this node. So we're going to use the node constructor, and the value we're going to give it is the value of this original node. And we're also going to take that copy and then add it to our old to new hash map. So old to new. So the old node is just node and the new node is the copy. So we're mapping the old node to the copy. And then we want to make copies of every single neighbor of the original node. So node.neighbors. Let's go through every single neighbor and let's run depth first search on that neighbor. And so basically, if we run depth first search on that neighbor, what it's going to do is it's going to return the copy that we end up creating. And with that copy, what am I going to do? I'm going to take this old node or this new node, the copy that we made, and I'm going to take its list of neighbors and I'm going to append to that list of neighbors this the return statement from this depth first search call. So let's copy and paste that in here. So that's all I really need to do, depth first search, and add it to the neighbors of this copy that we just made. And once we're done making all the copies of the neighbors, then we can return the copy that we just made in the current function call. And it's actually that simple, because Even though this is called depth first search, it might even be better to call this function clone, because cloning is basically what we're doing. We're taking the original node and creating a clone of that node, and we're cloning all of its neighbors recurrently.
Start with first node. Come here. So what we do is create a copy of the first node and add it in a copy. So we go to its neighbor. So once we go to this neighbor, we again go to the tool. So two will again call back this one. So for the two is the two created, no, two is not created. So we create another copy. So we mark two and what you could copy to copy. Then we'll again and then when copy, then we'll again come here. We'll go to the two neighbor. Okay, two's neighbor. So for one, so once we do one's neighbor. Okay, so once we add we are in once we are in we are on one, whatever the two will return. Okay, so two will return once the two is created. Let's say for the first iteration, it's written. We'll go to the two to come here. Again, for the two neighbors, we will have one and three. One and three. So 1 and 3. So we come here, we check if again we will come here, we check if one exists, because we are passing one. So one exists, we will return one. So for the two copy, we'll have one. Okay, for the two neighbor, we'll have one. So what for one value is one, whatever the this will return. So two is not created. This is not added. Two is not added. So for the this one, so for two neighbor, we have one. Then for 3, we'll again call back. 3 is not created. We create the 3. We'll go to the 3 neighbor. Three neighbor will be 2 and 4. For the 2 and 4. So let's see. It will be something like this. Okay, we'll start from 1, 2, 4, 3. Okay. So first we create 1. We go deep inside and we go create 2. Okay. So once we create 2, we check if one its neighbor exists or not. So 1 already exists. So what we add, we append its neighbor as this one. Okay, and we haven't appended still. Whatever this we go to this node, we call its neighbor. Whatever this will return. Okay, so this will this has not returned anything. Still, we just do this. Okay, then yeah, we'll go inside the. Yes, we'll go to two neighbors. Two neighbor will be is 1 and 4. So 1 is already created. So for 1, we'll come here. When we call again 1, 1 is created. So what we do is append 2 neighbor as 1. Okay, so 2 will have now neighbor as 1. Okay, so in second iteration, we'll go to 4. So we'll come here. From here we'll call the 4. 4 is not created. So we'll create a 4. Okay. Once you create the 4, okay, now the 4 is created. We call 4 neighbor. 4 neighbor is 2 and 3 and 4. So once we call 2, so 2. So this will call 2. It will come here. It will come here. 2 is already created, so it will return 2. So this will return 2. So 4 neighbor. 4 neighbor will be 2. Okay. So now for 4, we'll have 3. So for the 3, it will come here. It will go to 3. It will call here. 3 is not created. It will create a 3. Okay. Now it will create a 3. It will check for 3's neighbor. But for 3's neighbor, we have 1 and 2. So what will happen? It will call 1 and 4. So 1 is already created. So it will once will 1. It will return 1. So this will append whatever the current. The current is 3. So 3 neighbor will append 1. So we appended 1. Then its neighbor will have 4. So 4, what we will do? We will append this one. Okay. We will append this one. So we'll go back to 4. So for 4 we created this, we just appended this. Okay, we added it as its neighbor. Okay, so what do you do? When you come up to 3, we check its neighbor. So it neighbor, if already exists, we do this. If it does not exist, we create it. So we create it and return the copy. Okay, that's it. So it will come here. So we'll have one iteration. Okay, so now for 3, so 3, we have done this. Then it will come here. It will return 3 itself. So it will return 3 itself to this one. So this will create this node. Okay, so we'll add 4 to this number. Okay, we have return 3. As for 3, we do this 1 and 2. We went through the neighbor, we connected it, then we return itself. So it will return 3 itself. So it will return 3 itself to the 4. So uh, when there is 4, we have called this one. So we'll get 3. So we add 3 as its neighbor. Okay, again we add 3 as its neighbor again. First we add this as its neighbor. Now 4 as 3's neighbor. Then we'll again go back to the 4. Then we go to the 2. So 2. So when this, for this we'll return 4 itself. So this will be happen. So 4 again 2. For 2, what we will get? For the 2 will return 2 itself. So this will return 2 itself. Okay. For 1, once the 1 we have called 1 is not created. So once never we did this, but we did not never call this one. So we call 3. So once we call 3, so 3 already exists, so we add 3 as its neighbor. Basically, what is happening? We create 1, then we create 2, then we create 4. So when you create 2, we add this. Okay, as a 2's neighbor, we add 1. Then when we create 4, we add 4 neighbor as 3. Then once we create 3, we add 3's neighbor as 4 and 3's neighbor as 2. So we have created first one direction graph. Okay, now what we're going to do is for this it will return 3. So for when we, because of recursion, at the end of 3, all the neighbor, we look through all the neighbor of 4, it will return 3 itself. Okay, because we created the 3 copy, we go through the 3, then we return 3 itself. So we'll return 3 itself. So we'll add 4 neighbor as 3, then we'll add 2 neighbor as 4. Then what we'll do, we'll add 1 neighbor as 2, and then we'll add again 1 neighbor as 3. Okay, so this is how. So let's write this code. Okay, let's what do we do? Let's create another function. Okay, let's name it. This will return node. Okay, a node. What do we do? Let's create a graph. Map of hash. Okay, it will get we'll have 2 nodes. Okay, and okay, what we call it, what can I call it? Link. Okay, link old. Okay, link old and new. So what I'm going to do is we start from the first node. Okay, check if if our first node already exists. So let's say if okay, old and new but find node. Let's say if our first node does not exist. It equal to so if linking does not exist, okay. If it does not exist, what you do is simply create a new node and link it, okay. So what you do is create a node with do n node this add its node, whatever the node is value, okay. Once we add the node value, what you're gonna do is whatever this node our current node is, we will go through its neighbor for each node chb or neighbor in puts chb or neighbors, okay. What you're gonna do is we're gonna call yellow, okay, function chb. So this whatever this will return, it will be the our current cloned node neighbor, okay. This will be our first, if even before this is null. So it is not equal to null is if our current node is already in the old node. What is this? We just return our new its value, whatever the our node is. If it exists, we return it, okay. Otherwise, what we simply do, we simply create a node, we'll go through its neighbor, and then whatever this will return. Okay, so let's say if return if already exists, it will return this. If does not exist, we'll again call this one, okay. So it will return whatever it will return, we'll do and that GHBO such. Whatever our current node is, create newly created node, whatever this node clone node will return for our neighbor, whatever this will return, we'll push it to the this one, okay. But if this will return this one, we'll push it one. If this will not return, we'll keep on going through the one loop iteration. Then we'll when we return back, okay, we'll return, okay. So copy. See, If we totally just return it does not exist in this one. It's see we need then we need to do is add link. Once we create this with old and new, okay, we need to link old and new. So what we're gonna do is node is whatever the is, we're gonna push it to the this old and new, because we are never pushing anything to the old and new. Okay. You see here, not a error, consistent with null pointer of right node. Okay, sorry, that's also the case if node can be null too. Okay, so in the first iteration we check if it does not exist, we are trying to access the null value of this one again. So if node term just return, then still we'll have one specific problem. We will return this, we are returning empty is, we are returning empty. Okay, so what is happening for this one, we have node. What is happening, we have one node. Okay, we don't have so okay, inside this it's a neighbor. Okay, so we have one node, it will come here. So our first node is not null, not null. We check if our first node is in our link to older name, it is not. So we create a copy, we add it to the link node. We don't have any neighbor, we just return this. Okay, so return whatever this new node we have created. Okay, so this is so this works. Okay, simple BFS we could have created, we could do this on the node. We use BFS, we see if we create a what it is, simply create a hash map to have a list of old and new. We check if new if the node already exists in our hash map. So we have already created, we just return the whatever the created node, new created node is, and then otherwise we just keep on creating the node and adding it to the this node. Keep on calling, just keep on calling, and we keep on going through its neighbor. Okay. So first we create one directional Then once we start to return n, we'll create another direction for you for what called undirected, uh, until we keep on using inside this for loop. If we keep on going inside this for loop, we are never returning this. We have once all of this for loop is completed, we'll have what we call is uh, directed graph. So one directed. Once we start to return n in a recursion, we'll start to create another what do you call graph. Okay. Could have done this if you are to use this, we could have created all the nodes. Then once we have created all the nodes and have this again click to old to new, we could have gone from its neighbor, like we could have gone through node and node's neighbor, and we could have check again to the data hash map, and from the hash map we could have gotten the new node. If we do not want to do recursion, we could have just done that again. First look through all this, just done that. So now let's move on to the next problem. So this is the next problem. False indicators. This is a premium problem. So let's solve it tomorrow. So we'll solve this problem tomorrow. Okay. So today we solve this one problem. Okay. Cloning a graph. How to clone a graph. So